Hi, my name is Razvan Popa. This is a introduction to Git on Windows. We'll be going through a few basic notions, and then I will show how to install and configure Git, and then I'm gonna start a new .NET Core project, pretend I'm a user, write some C# code, compile, commit, so basically save to Git, and then pretend I'm a different user who wants to make some further changes to that program, and then wants to contribute with some pull requests, wants to contribute the changes back to the original repository. And finally, we should be doing some recap. What is Git? Git is a distributed version control system. This is its homepage, git-csm scm.com. It's a distributed version control system, so it's something that allows you to track changes, store the history of the project, and go back to older versions. It allows you to try different things without getting mixed up in your changes. The fact that it's distributed means that you don't need a separate server to store this repository and to store your project files. You can simply get it on your local machine, on your laptop or desktop, and then you can also end up using a server, but that is not necessary. GitHub is a platform for developing software. It uses Git and it enhances Git, but it is not Git. This is what it looks like. It's actually quite pretty. In addition to versioning, so the fact that the things that it brings to the table is it helps you with collaboration, it helps you discuss changes, it helps multiple people work on the same project. It helps with documentation. You can create documentation pages, wiki pages, and then there are also tools for you to build and deploy your project. A few Git terms, repository. Actually, the first three terms pretty much come together. So repository would be both the .git folder and the working directory. The repository will contain everything that's related to your project, including the history. The .git folder is a special directory storing the Git repository information, which is the history and any remote repository, so other parts where this project can be copied. While the working directory is pretty much where you can see your project files and work on them, change them, add things, build and deploy, and build actually. Staging area is a separate place where files get put before being committed. We'll be discussing about this a bit further down the track. A commit is a set of changes that gets saved to Git. So whenever you want to save your changes to Git, be that new files or modifications to existing files, those would be put together in a commit and then stored in Git. A branch is a label that is attached to commits, and it moves in the history of Git, and it helps you to track changes as you make them. A file can be in multiple states in Git, and I'm actually going to open this image in a new tab and zoom in a bit. So a new file that you have just added to the repository is untracked. Git doesn't know about it. In order to allow Git to know about it, you first stage it. So you add the file which makes it be staged. So it goes into the index or the staging area. And then you commit it, which makes the file be in Git and it's unmodified. And then if you want to remove the file then it becomes untracked, which means you remove it from Git. Or if you want to edit the file, that takes it to the modified stage or the modified state, from where you can either undo the changes, which takes it back to unmodified, or stage the file and then commit the changes, the new changes again to Git. As I said before, a Git commit is how we store our changes in Git. A Git commit contains the changes that you add plus some metadata, some meta information. So it contains the file system changes. It knows which are the parent commits. So let's say you make a few changes and then you make some and commit and then you make some more changes. The second time you commit, it will know that you have committed previously. It will point to the parent commit, to the previous commit. It also saves the author name and email and the date of the commit so that you know who, when committed. And there's a commit message which helps you identify what the purpose of the commit was. And all these things, they get put together into and hashed, so transformed by some mathematical transformations. And the result of those is a hash, which is just a string of digits and letters, looks something like this, and sometimes is abbreviated as the first few characters, the first 4, the first 8 or something. So you will not always see the full hash, you will sometimes see the abbreviation of it. Git branches allow us to save changes to Git in isolation from each other. So you will have a main branch or a master branch that is maybe the stable version of your project. You deploy from that, you deploy to production. And then you can have separate branches for instance, for test, for development, for some other environments. You can also try out branches on your local developer machine I give here a couple of examples. So if you want to just try a few changes, you can create a separate make fonts prettier branch and then try the font changes there. And at the same time, without stepping on these changes, without interfering with these changes, you can have another branch, test 1, 2, 3, where you are able to test another version of some package or library that's included in the project. And you can save these changes separately to Git and they will not interfere with each other. So there is a default branch in any repository and it's called master or main, or you can even choose a different name if you want. Commits go one after another in branches. So you have one commit and then the following, even that says that it goes after the previous one. Here's the nice picture. So this shows us that we started with branch we have two branches, the master branch and v10 branch, and there are 3 commits in these branches. The latest is f30ab, so as I said before, this is an abbreviation of the hash of the commit. It points to the parent commit, which is the previous commit, 34ac2, which also points to its parent commit, 98ca9, and this would be, in this case, it would be the first commit in the repository. So here you have the full history of the repository, 2 branches, 3 commits, and the head indicator, the head label, is something that tells us that the master branch is currently checked out. What does checkout mean? Well, checking out a branch is how you change between them, because if you want to make changes to master, then you have to check out master or switch to master. If you want to make changes to v10, you have to check that out. So create a branch with git branch or git checkout-b. Git branch creates a branch but does not make it active, whereas git checkout-b creates a branch and then immediately makes it active. You can switch between branches with checkout or switch. So git checkout or git switch. Git checkout -b is used for creating branches. Git checkout without the b would be used for just for switching between branches. A few more git commands. The status of the repository can be shown by the git status command. So all of these commands are activated or are invoked by doing git command name, git status, git log, git clone, git branch. Log shows the history, which would be something like here. You would see these 3 commits in descending order. So this would be the most recent commit at the top of the screen, and then this and then this. There are many options for filtering and displaying the commits, including filtering by author name, by date, by branch, and lots of things, as well as I know there's an option for displaying the log as a tree, or for having an abbreviated view of the log. Clone copies an existing repository, and actually we're going to use all of these commands. And branch manages branches. Yeah. To install Git, you go to Git's download page, and you can pick up between Mac OS, Windows, and Linux. I actually have the kit already. You install the version that is appropriate for a computer. It automatically saw that I am on Windows, so it's pointing me to download for Windows. And you install that, and then you test that it installed correctly by running this command in a command prompt. So git space, git space -- version. Again, so you run git commands by doing git space and then the command. Now this is me not being sure where I saved my Git installation kit, so bear with me please. This would be the current version, 2.34.1. And I'm running it. It's mostly a problem of doing next, as is usually the case with Windows programs. There are lots of settings and it's going to take a bit of time. Yep. I'll just do next now, and then you can uninstall and then reinstall again, or change some of the settings via some commands in the command line. So it's not a big problem if you don't get it all correct the first time. So when it's done, I should be able to do git -- version, and then it should show me, I have an older version here, so it's 2.32. It should show me 2.34.1. Nearly there. I just wanted to show you how easy you can get away with. So just doing next will help you install Git, and then you can uninstall it and reinstall it if you want to choose different options, or just run some things in some commands in the command line. So I'm gonna do git -- version, git space -- version, and it's 2.34.1. So I'm going to pretend I'm user Joe and start a new .NET Core project. Joe. .NET new console. What I have here is the project file and the program. And I'm going to use, so Git comes with Nano, which is a console editor. It's pretty easy to use. You have all these commands here. So the caret upward pointing arrow means you have to press Control. So if I want to make a change here, I'm just going to use my arrow keys and then say console.writeLine awesome. And we'll write out. Yes, enter, and then Control X to exit. And I can open it again and see, yep, it's saved my changes. So I'm gonna Control X again to exit. I'm gonna run my program. And being .NET, it takes a bit of time. Right, so I see my two messages, and what I want to do now is, because I heard Git is so awesome, I will initialize and configure my repository. And to initialize, I'll just do git init, and it's telling me that it initialized an empty Git repository, and it's showing me the .git folder I talked to you about earlier. So I'm going to do a git cd git just to have a look here. I'm gonna type my config, not too much there. I'm gonna go back and I need to configure my repository. I'm gonna skip ahead a bit, and there's not much information here, but basically I have to set up, before I make any commit, I have to set up my name and email, and I can do that with git config. Now, Git configuration can be done per machine, per user, or per project. So in this case, I want to have per project configuration, per repository, sorry. So I'm gonna do user.name Joe, and I believe I can do --local. And then user.email joe@server.com. Then I'm gonna do git config list local, and I can see my two settings here, so the name and the email. And now I can do, we discussed about git status to show the status of the repository. And I have the program file and the project file. Program and project file is telling me that I have untracked files and no commits, and I can use git add to include in what will be committed. So going back to the lifecycle of the files, I have all my files in the untracked files state. I'm gonna add the files and make them staged. Doesn't say anything, but if I do git status, I'm gonna see them as green. So I've added program CS and CS and they are green now, and these files are untracked. So these are binary folders, and you wouldn't want to normally store them in the repository in the source control. I'm gonna make a first commit, and you do that by git commit, and -m means message. So I'm gonna say initial commit, and it's changed to files, and it's created these files in the repository. So program CS and JavaSproj. If I do git status, I only see the untracked folders, and because I don't want to add the untracked folders, these folders, the binary files folders, to the repository, I'm just going to ignore them, and I do that by creating a git ignore file, where you can simply specify the files in a using a wildcard format the files and folders you want to ignore. I'm going to do Control X this time, and it's asking me if I want to save the modified buffer. Y for yes. Enter. And if I do a git status now, I shouldn't see the red bin and obj folders anymore. But I do see the .gitignore file, which is the new file I just created. So I'm going to add that to the repository because it's a good thing to store that. You want to have this same setting for everybody who uses this repository. So I'm going to add it, which makes it staged, right? Puts it here. I didn't want to do that. Git add.gitignore. And the status of my repository is that I'm on branch master and nothing to commit and working trees. So no changes, and I'm on branch master. I'm going to see which branches I have, and I'm going to do git branch, no branch, because I haven't created any branch, of course. Now I want to create a branch to... Wait, before I create another branch, I'm going to show you the git log command. So I have the commit hash, and I see that this top one is the head of the master. I see the author, I see the date and the message. I don't see, in this view, I don't see the files that were added, but you can parameterize the log command to show the files in the commit. This is the initial commit, and this is its hash, the author, and the date. So I'm gonna create a branch, check out -b. Right, and I can look at the log, and I'm seeing it's pretty much inherited. It has the same history as the master, but now you can see that we have two branches. Add one more right line and master. If I do a git branch -a, I can see I am on the add one more right line branch, but I also have the master branch. Gonna edit gonna edit the program file. Yes. Git status will show me that program file has changed, and I'm going to add it. Git add everything, which in this case will only be program.cs. So the wildcard here, the asterisk, is a wildcard, which means add everything that's not added. Add it as in stage it again. So add it here. It doesn't commit. You have to commit by the commit command to save the files to Git, to save the changes. So I'm gonna add everything. I'm going to status again, and I'm going to commit with a message of added one more right line. Git log will show me 3 entries. So initial commit, git ignore, one more right line. If I change branch, I said we can change branches with checkout or switch. Switch is a newer command. Pretty much everybody will know about checkout. So I'm going to do git checkout master. And if so previously I was on add one more right line, and I had 3 commits, but if I go back to master, I'm only going to have 2 commits. the initial commit, and this one, added git ignore. So what I want to do now is to merge, add one more write line into master. And it's telling me it just fast forwarded the file and now it's all good. So I'm going to do a git log again, and I can see that both branches, master and add one more write line, are on the same commit, which is 1d492. Just like this one here when I was on add one more write line. I'm going to create one more branch, and I'm going to show a conflict. So git checkout -b conflict 1, and this is just me adding a console.read key, which will wait for the user to press a key. .NET run. Wait a while. And now it's not ending, it's waiting for me to press something. I pressed K, okay. And I'm going to check out master again. So I'm on branch conflict 1. And we'll create a branch conflict 2. Yeah, I need to give the -b parameter. I'm gonna exit. Check out master. Right, because it's not modified, and I have modified it in the conflict 1 branch, but it's not modified in master as well. We'll commit here. You can also skip the message and then it will ask you for the message. And it's opened up Notepad++ for me. I'm gonna say added read key. And then when I close the program, the editor, and save the message, which you can see here, it's in my .git folder /commit edit message file. It will then know that it's going to use that message for the commit. And if I do a git log, I should see 4 commits. And the latest one is added read key, which I just added. You can also do git log --1 line, which is a much more abbreviated version of the log. So if I'm going to do a git checkout, I'm going to be on this commit, and I'm not even going to see this one, DC7. And I'm going to check out conflict 2. And I don't have the read key line, and I'm going to add just another write line. Yes. And git status will show me that it's the program CS file is modified. Commit git log. So it doesn't show me conflict 1 at all. I see that master and add one more write line are on the same commit, the third commit, and conflict 2 is on the fourth commit. I'm going to merge conflict 2 into master, so I'm going to check out, which means I'm going to bring this commit here into master, or rather I will move the master label to this commit, so then you would see that it's sharing the same commit number as conflict 2. And you do that with merge. So I'm on master because I just checked out master, and I'm merging conflict 2. Git log one line is showing me, as I said, so I am on master, head is on master. I'm also, this commit is in conflict 2. And now I'm going to merge conflict 1. I can still see, if I do a git branch -a, I can see all my 4 branches. I have master, conflict 1, which we haven't touched in a few minutes, conflict 2, which we've just visited, and then add one more write line. So I'm going to do, because I'm on master and I've merged conflict 2, I'm going to merge conflict 1 as well with git merge conflict 1. And now I'm getting a conflict, and I'm required to do something about it, because if I do a git status, I see that both conflict 1 and master have modified program CS. So I need to fix the conflicts and then run git commit, or I can just abort this merge command by running git merge -- abort. So I want to see what program CS file contains, and we know that this comes from conflict 1 and this comes from head, which is master. So this is Git's way of telling us that this part here comes from the head branch, which is master, which is the current branch, and this part here comes from the conflict 1 branch. Which one do you want to keep? Well, I'm gonna just remove these merge markers, these conflict markers, and I'm gonna leave both changes, both the one which initially was in conflict 2 and the one which initially was in conflict 1, and then I'm gonna exit with save. What's the status now? I have, if I do type program, I can see that I don't have the conflict markers anymore, but I still have to do git commit. So I'm gonna do git commit message Right, I need to add. I forgot to do that. So again, git status. I need to do git add. Again, going back to the manual. This is the life cycle. This is where I am now. I have a file which is known to Git, and it's modified from what it knows about that file, and I need to stage it. And I stage it by doing git add. So git add program.cs, git status. Okay, all conflicts fixed, which is good. I like it. I'm still merging, so I need to do git commit to finish my merge. What's that? I'm gonna go back. So fixed conflict for conflict 1, and I have fixed my conflict. I'm gonna do a git log --1 line. And interesting thing is that now we have multiple commits. So we have pretty much every branch was here, and then conflict 1 had this separate commit, and conflict 2 had this separate commit, and then they got put together. I'm gonna open a different terminal, go there, and then I'm gonna do a git log. So this is the current status, and I'm gonna scroll now to the previous log command. You can see here that previously master and conflict 2 were sharing commit 943. So previously master and conflict 2 were sharing commit 9.3, and now master has advanced with a new commit 6A1. So this is not a very good indication, but they have diverged, and then they have come back in this one here in the master branch. If I check out conflict 2 and do a log, I only see the commits that it knows about. So it doesn't know anything about DC7 whatever, because that's on a separate branch which it had nothing to do with. And it also doesn't know about 6A1 because that's, as far as it's concerned, it's into the future. Again, if I do git check out conflict 1 and then log, I see, the initial one, the added git ignore, the add one more write line, and then this one here. So this commit. Neither of these knows about the other's commit, and they don't know about the current commit that's the head of master either. So now that we have this thing here, we have a few branches, we have some commits, we have some history. I'm gonna pretend I'm a different user. And I'm going to clone Joe's repository. I'm going to remove that now because I want it to be in this exact folder. So I'm gonna do git clone Joe. I think O should do the trick, but then again I should maybe ask look for. So git, you can ask for help or look for help for any command with git help command. So clone, and this is going to open up the HTML file from your local install. And what I'm looking at is directory, so I don't need to specify any -o. So all I need to do is just git clone the the repository I'm cloning. And as to where to put it, I'm going to say a single dot, which means current directory. And there you go. Git log. I see all 4 commits. And I see one more thing. So previously, as Joe, I see everything as green, right? I'm on, actually that's good. So I'm on conflict 1 and I'm seeing these 2 branches in green. Whereas here I have a single branch, which is conflict 1, which is the one that's currently checked out. And it's because I cloned out this repository and it happened to be have checked out this branch, conflict 1. So I'm now on the same branch. I still have every other branch, git branch -a. They're all remote though, so they only this one is known as a local branch, as a branch in this repository. The other ones are known, but only as branches in the other repository, which is in the origin repository, which means Joe's repository. I'm just gonna make a brief change here. Actually, I'm not gonna save, so I'm gonna do git checkout master git branch A. I have master, which is set up, which is the same as the remote branch master. So I'm gonna do git checkout master at Joe as well, and the log. And then I'm gonna do a git log here as well. And they're both on the 6A1 commit. So now I'm like at the latest. And I'm going to make a new branch -b, my branch. Save, yes. Just want to see what I did, so maybe I introduced some subtle bug in my program. Press and then welcome to the party. Whee! And Git, I'm just gonna see. I am on my branch. I have modified the file and I haven't modified program.cs and I have not committed. So we'll add and committed, and I'm now going to push, because I want Joe to have my changes. I'm going to push these changes to Joe's repository. This should do it. No, it's telling me that my branch. So let's recap. Bob has a new branch which doesn't exist in Joe's repository. So Joe only knows about master, conflict 1, 2, and add one more right line. But we also have the my branch, so I'm going to have to use this command to push my branch to Joe's repository. And now if I do a git branch -a, I also see my branch. I'm gonna do a git log, and I'm on commit F71, and because I'm not on that branch, I don't see the commit. So I'm gonna check out my branch, and of course I'm on the same commit as Bob here. Right, so yeah, I also forked the repository as a different user, and we cloned by doing git clone. We saw that we can use dot as the current directory and tell clone to clone into the current directory. I created local branches, which is my branch here, and then I merged that back into Joe's repository. Now this is where the commit changes. This is where the pull request mechanism would have come into play, because in GitHub or GitLab or Bitbucket or any other software website, software creation website, you will have a mechanism for some contributor to ask for your permission to add some changes to your program, to your package. In this case, we just did a git push, and that did the trick, because we did git push in here, and then the branch appeared here. And also this command set upstream, you only need to do that when you have a branch in your local repo that's unknown to the origin repo. So if I make another change here, so git add, because we want to add, and then git commit. So I'm gonna say I'm testing that I don't need to set upstream now. Yes, save the changes, was committed, and then just do git push, and I have an error. So it's telling me that I have a branch checked out in the remote repo, I guess. By default, updating the current branch in a non-bear repository is denied. So I'm gonna change my branch here, check out master, and then we'll try again to push from the contributor repository. So git push, and sure thing, all good. Git, I'm gonna check out the my branch again and see git log, and actually I'm gonna do git log first here. So git log, and testing no need to do set upstream is F3B, and I should see that in here in Joe's repository as well. And sure thing, I see it there. Testing no need to do set upstream, and it's the same commit. Pull requests, yeah, so pull requests are not in Git per se, they are in GitHub or GitLab, Bitbucket, etc. And it's when, well, actually did a bit of a demo here. It's when other people, so contributors, want to contribute some changes to your project that they will create pull requests or merge requests to ask us to incorporate their changes in our repository. And if I'm gonna look at, let's say, github.net, we should see some examples of, we have issues. So I'm gonna zoom in a bit. So what does GitHub give us? I mean, I've tortured you through command line hell, and there are actually quite a few good GUIs for working with GitHub, with Git, sorry. You should be able to use Git Extensions or Sourcetree. I'm just gonna look them up. If I can spell them. So this is Git Extensions, and it looks nice like this. It shows you, remotes. So this would be where where you'd see Bob and Joe, or maybe, if you're in the new repository in Bob, you see Joe. This is where you see Git log, the history, authors and when were they committed and the hashes. So it's it's a better experience compared to command line, but it gives you less options. And Sourcetree, so now it's an Atlassian product. And if we're gonna see what it looks like, maybe look at the interface. Maybe not. Anyway, believe me, there are very beautiful UIs for Git. You don't have to use the command line if you don't want to. VS Code has extensions for working with Git, Visual Studio, and pretty much any real editor. And I said, so looking at GitHub, this is what GitHub looks like at the moment. And people can see the code here. They can view issues and open their own issues and, go through them, which is like, I have a problem. I want to obsolete the unused static service point manager members. I mean, everybody has their own thing they want to change, and then when they actually, so this is me maybe coming in and requesting something to be done, and this is me in pull request is when I have made the changes myself in a copy or a fork. This is what they call it in Git land. So Git, they call it the fork of the repository. When you copy somebody else's repository, I am going to then make the changes in my own fork of the repo, and then we'll create a pull request so that my change gets pulled to the main repo, which is this one here. And if you go into one of these pull requests, you can see there's a conversation, there are commits, there are all sorts of checks which can be added. Doesn't look very fancy here actually. Yeah, but anyway, lots of things happening here. So it's really more than just Git. It gives you much more. Well, it's a very short recap because it turned out not to be such a short introduction to Git. So Git allows us to track the history of software projects. We can go back in time, and I didn't show you how to do that, but I will show you now. Let's say I am Joe and I want to get the repository in the state where it was just the initial commit. I'm going to reset and use this hash. And if I do git log now, what do you know? I'm on the first commit. And if I want to have a look at program, I see everything because I should have done something else. So I'm going to do git reset now. No, git checkout master. And now I'm getting in trouble. I'm just gonna remove this file for now because it's going to be, this is something nice. So I have some changes I don't know how to get rid of. I'm just gonna check out master and then the changes should appear. I have my git ignore file. Git ignore. And it has the correct content. I have my program.cs and it's after the conflict. And I don't have any changes. So it's all good. And if I look git log, I'm not seeing the my branch, but I have the conflict fixed, which you can also see here. So these two lines were in the conflict. So now I'm going to try again. I'm going to go to, let's say this one, the second commit. So I should have the git ignore, but I shouldn't see these two lines. This is going to conflict. So nothing about conflict or read key. But I'm going to do this -- hard, which is not saving any changes. So I have my git ignore. I have my program. And I only have 2 lines, hello world and awesome. I don't even have this commit, so added one more write line. And if I want to go back to where I was, git status just to check, nothing. So I'm going to just git checkout master. You shouldn't really play with reset. But anyway, git log, I mean, you should first understand better what it does, and it's out of scope for this brief, which is not so brief anymore, introduction. So now I see that master is where it's supposed to be, and it's after the conflict, so we're in a good position. I showed you how you can go back to previous points in time for the project, and we have all the history available locally. So the new repository, Bob, had all the history that was in Joe. So that's it. I hope it makes sense, and I hope you don't hate on Git and working with it from the command line. Bye.